why it is that I'm doing that and sort of what qualifies me to do so. Domain-driven design, if most of you may or may not be aware, is actually a pretty old technique. It celebrated its 10-year anniversary, I guess, about a few months ago. So it's been around for a little while. Not a lot of adoption yet, and that's quite unfortunate. I have been using it for about 7 years, though. And to be honest with you, it took me about 2 years to really understand what domain-driven design is beyond the domain-driven design theory. So what I aim to do in the first portion of this talk is actually to give you a distilled version of what I think domain-driven design is, if you will, to save you the 2 years of time to figure out what domain-driven design is supposed to be. And finally, we'll be talking about how domain-driven design maps to Java EE in particular. Okay, so Java EE is my domain area. It's what I evangelize, and I actually believe that there is actually a very good mapping between domain-driven design and Java EE. Actually, let's turn off the sound because this is such a small room. I can just talk over it. Oh, I see. All right. So we have to. Sorry about that, guys. We have to tolerate this sort of white noise. So hopefully it doesn't drive you insane by the end of the day. And if it does, oh well. Okay. So how many of you here have heard of J2E blueprints or Java Pet Store? Okay, a few people. All right. So I was an early adopter of Java EE, and actually I was an early adopter of the J2E blueprints or the Java Pet Store also. The Java Pet Store, it's unfortunate many of you haven't heard about it, but it's actually very important in our industry. It was the first sort of effort to formalize how well-structured enterprise applications are supposed to look like. If you saw enterprise applications before the J2E blueprints era, it was quite frightening, right? I mean, there really wasn't very much structure to these projects at all. It was sort of cowboy architecture, whatever you feel like architecture. So the J2E blueprints played a very vital role. In fact, it has a very profound impact on our industry. How many of you have heard of terms like DTO, DAO, maybe something like repository, lookup pattern, proxy? Guess what? These were all terminologies that were formalized as part of the J2E blueprints effort. Okay. In fact, even after 10 some years, actually 15 some years, when I still go to projects, I still see basically they're applying J2E blueprints without necessarily understanding that they are. Even things like session facade, right? They're applying things like session facade, but they just don't know it, which is good. It's a good thing, as I said. It's a good positive effect overall. The problem is that the J2E blueprints themselves are not necessarily without their own set of problems. Okay, so the biggest problem with the J2E blueprints were they were designed to solve specific problems in J2EE. Okay, in a very early stage of a technology, and also many of the design patterns are very tied to that technology, not necessarily solving the problems that we have today. Most importantly, the J2E blueprints kind of take you away from the core of why you want to do Java in the first place. Okay, Java in the end is an object-oriented language, and it happens to be a very nicely implemented object-oriented language. And when you actually adopt something like the J2E blueprints, it sort of takes you away from that. It takes you away from the basic concepts of object-oriented analysis and design. And I'll tell you why that is in a second. Why that is the case. Do we have an alternative? Is there something that does allow us to really take full advantage of Java's object orientation and things like object-oriented analysis and development? And the answer is yes. Okay, so this is what really the core value proposition of domain-driven design is supposed to be about. It's supposed to be going back to the roots of OO. Now, interestingly enough, Java EE as opposed to J2EE fits the domain-driven design model extremely well. In fact, there are some key philosophical alignments that make for a very good system for developing domain-driven designs. In fact, for all of the 7 years that I've been adopting domain-driven design, I've adopted it in Java EE. So what I wanted to do is sort of recreate the Java pet store effort. However, this time utilizing domain-driven design instead of using sort of the old school J2E blueprints or pet store type design patterns. And in fact, that is what this project is all about. It's called Cargo Tracker. As I said, it's a project that I maintain with a few of my colleagues in Oracle, also helping me out, largely in our own time, right? This is not something that is a part of our day job. It's sort of whenever we have some time, we maintain this because we believe in it and we believe that there's a true value proposition to doing this sort of thing. Okay. All right. So here's the big challenge. Domain-driven design is not necessarily a very simple thing to explain. It's very interesting to try to explain this in about a half-hour time frame. But I believe I can do it. I believe I can get you almost 60 to 70% of the way there. Guys, there's no reason to stand. Please come on in and sit down. Make yourself comfortable. We still have 50 minutes to go. I don't want you to be standing around. Just a moment, sir. I don't want you to be just standing around here. Yes, sir. Please. Right, that's what I intend to do. Yeah, for a good bit of this talk. So no worries whatsoever. I'm just going to let folks settle down just for a minute, to get themselves situated. You guys are all right-wing people. No, I'm kidding. Okay. All right. Okay. So how should I do this? How should I attempt to explain? Good. You're a man after my own heart. All right. Okay. So what I can do is actually give you the basic gist of domain-driven design using this one diagram. Believe it or not. So what is this diagram? Is it something that I invented? Well, no. Okay. It's not something I invented. In fact, I don't want to be inventing this. This is a diagram that is relatively well known in the domain-driven design literature. If you pick up a book or an article or what have you, they'll have some derivative of this image. So if I can, in the next half hour, give you a basic understanding of what this image is, you'll basically have a good understanding of domain-driven design. So let's get started and let's first explain, well, what is domain-driven design in the first place? So as the name implies, basically it's a way of developing software that keeps the domain as the emperor, right? The domain is all important. More concretely, what you are trying to accomplish in domain-driven design is design software systems that very much mirror the real-world problem that you're solving. Okay, so if you look at the software, and you go and take a look at the real world, you'll be able to see, oh, there's not much of a difference, right? We're basically trying to do exactly the way things are, model things exactly the way things are in the real world. And guess what? That is the value proposition of object orientation, of object-oriented analysis and design. That is why that's what really it's all about. And that's what the object-oriented principles are really trying to accomplish. They're trying to help you write software that looks like the real world. Design, you do not need to incur that translation cost. And hence, it results in also more robust, more agile systems, right? There's some room, I think, still over there, and also some room over here also. Okay, moving on. So there's some fundamental building blocks that help you design domain-driven design systems. If you will, these are the new age design patterns, okay, for domain-driven design. So let's take a look at these. The first one to talk about is the entity. And in fact, the entity is the most important design pattern to understand in domain-driven design. What is it? Can anyone take a guess? Persisted, maybe. Okay, so let me explain. An entity is essentially an object in the real world. Okay, a thing in the real world. So a noun, if you want to think about it in terms of linguistic semantics, right? In fact, most of the things that you deal with in terms of systems, in terms of the real world, are nouns, right? A user, a book, a catalog, an order, a car, an airplane. These are all things. These are objects. And what entities are representations of the objects in your system. The big distinction, though, is that entities also have to be uniquely identifiable. Okay, so you can think of this as sort of an ID field or a ID field inside of inside of your database record, right? So it's uniquely identifiable in some way. The other big distinction of entities, though, is that entities have both data, okay, meaning Java properties and fields, whatever the modifiers may be, but also behavior. Okay, that's the novel thing and the big difference between classical J2E design patterns and domain-driven design entities. Okay, and we'll see how this is. And again, this is very much intended as to how object-oriented design is supposed to be. Okay, an object isn't just a dumb data holder. Okay, an object has properties, but also methods that are not simply accessors and mutators, but also behaviors, things that you do to this object that are very close to the data that's being modified. Okay, the second design pattern that you should understand, or concept that you should understand in domain-driven design, is value objects. And value objects are close cousins to entities. Okay, they also are nouns, things in the real world, things in your system. But the big distinction, and they also have data as well as behavior. The big distinction between an entity and a value object is that a value object does not have an identifier of its own. Okay, so the question you ask is, well, how do you then manage this object, this thing that is not uniquely identifiable? Okay, well, the answer to that is usually a value object will always be associated with an entity, and hence the entity's identity is actually the identity of the value object. Okay, so let's think about some examples of what this might be. But more importantly, I guess first let's try to understand, why do we need this thing, value object, in the first place? Okay, well, this also has to do with the real world. Okay, in reality, in the real world, things are not simple, right? Things are composed of other things, right? So, for example, this table is composed of a surface, 4 legs, perhaps some supporting things. This chair has a seat. It has some armrest. It has a backrest. Okay, these are all components. And in software, that's to the extreme, right? Most software will be, most things, most objects, most nouns in software will be composed of other complex things. Okay, so these dependent things, okay, the things that compose other things, are really the value objects. Okay, so for example, in my case, let's suppose you're writing some robot that is supposed to simulate me. Okay, so me, Reza Rahman, I have an identifier, probably my name. However, I'm composed of several things, right? I'm composed of my clothing, perhaps my watch and the like. So these things are indeed value objects, right? They do not. It doesn't make sense to uniquely identify them, okay? But they do inherit identity from the fact that I own them. Okay, I have a containing relationship with these objects. Okay. The next concept you should understand in domain-driven design is something called aggregates. Okay, and what is the purpose of aggregates? The true purpose of aggregates is to manage complexity by modularizing your domain. Okay, so in most non-trivial systems, if you try to have a very flat domain, meaning you create a mental map of every single value object and every single entity in one large chart, okay, how would that thing look like? Right? Not that terribly manageable, right? You wouldn't be able to consume domain and be able to manage it very easily. Well, the nice thing is, in real life, most things are actually grouped. They naturally group themselves together into subgroups. Okay, so each of these subgroups are actually called an aggregate. All right, an aggregate in classical domain-driven design will have just one aggregate root, and that is basically the most important entity in that aggregate. Okay, so generally speaking, an aggregate looks something like this. So you have a root entity object. Okay, that's perhaps the most important one. Let's say an insurance policy. Okay, and perhaps there's another little aggregate that says insurance user or policy holder. Okay, and then you'll have a bunch of child objects in a bunch of value objects and entities related to these. So perhaps a policy may have coverage information or liabilities, assets, payment information. That would be part of the policy object or policy aggregate. And on the user side, you may have things like address and dependent information, perhaps job history, and the like. Okay, so those would be part of the user aggregate. Okay, so you'd have two different aggregates, and we'll see more examples of this when we dive back into sort of the more of the example code. Okay, the next concept to understand in domain-driven design. I'm trying to accommodate other folks that are coming in. Do you guys mind trying to sit and please could you try to make some room for these folks? Please come on in. We still have 40 minutes to go. Pardon? Oh, okay, yeah, very important question. Okay, so for this particular session, I don't particularly care if I cover everything that's on my agenda. What that means is that I would rather you understand these concepts rather than me simply moving on. Okay, so if you have questions, let's discuss them now. Okay, as we go along. Please don't wait until the very end. You had a question, I assume. It is not an abstract class whatsoever. In fact, it's not necessary. The only OO object-oriented construct that you have in terms of aggregates is packages. Okay, so you'll have a package representing a particular aggregate, and under that package you'll have a root entity, okay, an important entity, and perhaps some other less important entities and value objects. And we'll see how this looks like certainly in terms of the example code. Hopefully we can get to that. But no, it has nothing to do with abstract classes whatsoever. Abstract classes generally will be a construct of creating entities and value objects. Okay, so an entity may have an abstract root. Okay, it may make use of inheritance and encapsulation and the like, and abstraction. Okay, any other questions? Yes, sir.
Traditionally, we have these closure concepts which are only with data center and data part. The entity is similar to that, or it will have some business methods.
Correct. So that's the big distinction, right? These getters and setters are a very poor way of using object orientation, right? They are methods indeed, but they're simply nothing much more than mutators and accessors of data. The big distinction here is that entities and value objects indeed will have behavior. Okay, so it will be things that act upon that object. Okay.
So many times you need multiple collaborators when you write various.
Correct.
So does the domain-driven design provide a way in which you can properly organize?
It does indeed. So we'll take a look at that in a second. Okay. Okay. Any other questions? All right. Very good. Moving on. Okay. So the next concept to understand is repositories. Okay. So let's think about this for a second. So far we have this very nice idea of objects and a domain, but these objects are simply things that live in memory. Correct? What happens when you restart the machine? All these things are going to go away? No, right? In most applications, the reason they don't go away is because we persist it. Okay, we save it out in some kind of persistent storage. So in domain-driven design, you're essentially going to try to isolate that mechanical bits of persistent actions, okay, outside of your core domain. Your domain is essentially supposed to be a model of your business domain, right? So you shouldn't have infrastructure concerns like saving out to a database there. So what you do is that you create this abstraction called the repository, okay, and you put in all of the database interactions there. Okay, so essentially CRUD operations, okay, that act upon entities and value objects. This sounds very familiar, right? What does it sound like? DIO, yes, okay. So question then you should ask is, well, what's the distinction between a DIO and a repository? Okay, so in classical J2EE design patterns, a DIO essentially maps to one logical entity. Okay, so every single entity you have will have a corresponding DIO. In this world, a repository does not do that. Okay, a repository will map to an aggregate instead. Okay, so the idea is that the repository acts upon the aggregate root, and the aggregate root manages the rest of the persistent relationships. Okay, so it's if you will, it's a coarser grained form of a DIO. So you'll have less repositories, than you would if you were modeling it using classical J2E blueprints and DIOs. Yes, sir, you had a question.
What I think is, I have multiple attributes. Every aggregate will be mapped to one repository, or rather, one repository will map to one attribute.
Yes, correct. That's exactly correct. Okay. All right. Moving forward. All right. Now this is factory. I won't spend a lot of time in factory, okay, because we want to move on. I want to talk about more important concepts instead of talking about factories. But let's talk about factories very quickly. By and large, remember that you have aggregates and aggregate roots. Most of the time, when you come to creating entities and value objects, you can get away with just creating a new operator, using a new operator, and just doing a few getters and setters to set up the aggregate root properly. Okay. However, in some cases, your business logic may dictate that the act of creating these entities and value objects are in fact quite complex. Okay. So what you do in order to manage that complexity is introduce another abstraction called the factory. And the factory's sole job is essentially to create entities or value objects. Okay. Generally speaking, factories will implement the singleton pattern, but more importantly, perhaps something like the builder pattern. Okay, is something you would apply in the factory concept in domain-driven design. Right. So in the real world, things are generally composed of verbs and nouns. Most of those verbs that you have in your system will be manifested as behavioral methods in your entities, right? However, in some cases, there may be verbs that are so important that in fact they are peers, okay, of entities rather than behaviors of entities. Especially if it is a verb that acts upon multiple entities and value objects. Okay, so this is what a service is. Okay, a service is essentially modeling an important verb or important behavior in your system. So let's talk about some examples of some of this. So in insurance, there is. Anybody here from the insurance domain? Nobody from the insurance domain? Auto, finance? You are? Okay. So tell me, what is the most important verb in insurance?
Automobile.
Automobile. Okay, as in like manufacturing automobiles. Okay. All right. In insurance, the example is underwriting. Okay. So what is underwriting? It's basically taking a bunch of information about a policyholder and determining how much coverage should they get. Okay. Anybody here from logistics, transportation, that type of thing? No? Okay. So in transportation, another very important concept is routing. Okay. So it's basically taking a bunch of information and figuring out, okay, what route should this bit of logistics follow, right? These are all important verbs, right? Underwriting, routing. And I think if you think about most of your domains, you'll find such important verbs, okay? And these map generally as services in domain-driven design. Generally, these guys are going to be stateless, okay? They are not going to hold state, okay? They're going to be stateless objects and not have, essentially, they will simply map a set of behaviors, okay? And not necessarily any data. In fact, they probably won't have any data associated with them whatsoever. And by and large, services may also follow the pattern of functional interfaces. Okay, anyone know what a functional interface is? It's just essentially an interface that has one method, right? It does really one thing, and that's very typical of the services pattern. And that's it in terms of this portion of what I want to cover of the very basics of domain-driven design. Okay, so now you essentially have an understanding of what the domain analysis part of domain-driven design is. How are we doing so far? Okay, yes, sir.
I see that the service is more of a functional interface, yes.
Mm-hmm.
But a single method what I was going to have will be closely related to the aggregate which has the actual modularity.
Yes, so the services will. It's not a requirement to do so, but yes. Pardon? Repeat the question. Okay, repeat the question. So his question is, services are functional interfaces. They do something, a verb, in the system. Well, if they do so, they're typically acting upon entities and value objects, right? And the answer is yes. That's typically true. Okay, so what will happen here is that that functional interface will take value objects or aggregates or entities as arguments and act upon them, and they may surface a altered state. Okay, they may alter the state of those entities.
But I don't see any relationship between an aggregate or an entity towards the services. It will be controlled through the design.
Correct. So we'll see about that in a second, right? So there is a communication layer that we haven't talked about quite yet. Okay, and we'll discuss that in just a second. Okay, are we otherwise okay for now? Okay, all right, moving forward. So if you talk about layers to Ruby on Rails developers or Node developers, what will they tell you? They're evil, right? You shouldn't have layers. They're a bad thing. They're horrible. You're a horrible person for creating these abstractions. Well, here's what I observed over a period of time. Okay, if you do not apply layering, what you usually wind up with in any non-trivial system is an artifact that I lovingly call the Uber component. Okay, anyone? I think you can guess what an Uber component looks like, right? So you open up a Java file, and your horizontal bar certainly, or vertical bar certainly, does a large scroll. Okay, meaning this object has maybe in the order of thousands of lines of code in it. Okay, why is this? Typically, the reason for this is that this one component, whatever it may be, right, whether it's an entity or a value object or a service, essentially is trying to solve more than one problem. Okay, so inside of these Uber components, there's business logic, there's presentation tier logic, potentially there's persistent logic as well. Because if you don't have any layering, then you must put all of these things in one place somewhere, right? And hence you wind up with this Uber component thing that eventually becomes unmanageable, right? So that is the problem that you're really trying to solve using layering. Okay, so what are you doing in layering? What you are doing is that identifying, if you will, cross-cutting, repeating behaviors in your system, things that are recognizable patterns. Okay, and then you're isolating them in their own abstraction layer. Okay, and that is how you're managing. You're stopping a whole bunch of types of work going into one layer, and you're basically creating a layer cake instead. Okay, you're segmenting out that bit of functionality in smaller components. All right. So luckily for us, certainly in the enterprise, we conveniently actually have a fairly well identifiable patterns. Okay. So these are, by and large, in terms of domain-driven design, the patterns that are well recognized. All right. So you have an interface layer, and what is this? Well, the most simplistic explanation of this is that this is the UI, right? Whatever it may be, your web layer or your Windows windowing layer or what have you. Okay. But in fact, it's a bit more than that, right? So in terms of domain-driven design, an interface is anything that talks outside of, receives input and provides input out to anything outside of your current system. Okay, so certainly humans are part of that equation, right? So certainly a UI is part of that equation, but it's not the only type of interface, right? There may also be other types of interfaces. A good example of this today is web services. Yeah, web services, and anything that has a remote protocol, right? Even if you're doing a file scan, if you're running a batch job, those are in fact interfaces. Okay, these are things you trigger triggers events into your system. Next, in the order of layers is something called the application layer. Okay, and the purpose of the application layer is to model use cases in your system, and we'll see how this looks like in code. It'll make more sense there. Basically, you're modeling here the important bits of functionality that your application supports. Okay, so if you talk to a business use case analyst, all right, this layer is going to be most sensible for them. All right. The other function of the application layer is to serve as a coordination layer between services and parts of your domain object. So does that answer your question? Right? That is the purpose of the application layer. That's where you do the coordination bit. Okay, if you need to do collaboration between services and value objects and entities, that's what generally where you would do it is the application layer. Okay. However, note the application layer may sound familiar to what, the session facade. Okay, in J2E. Can anyone now guess what the big difference between the session facade and the application layer in domain-driven design is? There is a simple ban on something. Business logic. Okay, you're not supposed to put business logic in the application layer. It's supposed to be purely about coordination, okay, and expressing a unit of work, expressing a use case, but no business logic. The business logic should either belong as a behavior of an entity or a value object or a service. Okay, so that's the big difference there. And of course, below that you have the domain, right? So the all-important domain. This is the heart of your application, and basically all what we talked about in the previous sort of diagram. Finally, we should talk about infrastructure. Well, all of this is nice, but in order for to do anything useful here, you need to interact with a framework or a system or an API of some sort. Okay, those essentially can be part of any of these layers. Okay, typically they will be below the domain layer and above and sort of at the top end of the interface layer. Okay, that's where most of the infrastructure layer code will belong, but in fact they can belong in basically any layer. Okay, they can have a mapping to any layer. Now, I didn't mention one important design pattern that we all know about. What is that one? I didn't mention it so far. Pardon? The one that everybody starts with. So Computer Science 101. Pardon? No, not singleton. MVC. Yes. Okay. So MVC is not a domain-driven design concern. Okay. So typically what will happen is you will implement MVC, but you will implement MVC as part of your interface layer. Okay. But you need, pardon? As part of your interface layer. It'll be an artifact of this layer here. Okay. Yes, sir. Excellent question. Okay, excellent question indeed. So yeah. So his question is, he's a very perceptive guy. Okay. So he's looking at this diagram and looking at the arrows, right? So if you notice, I have arrows going that are relatively hierarchical, okay? So these are are respecting each layer, but you have this one rogue behavior here, okay, that is talking directly, is going directly from the interface layer to the domain layer, okay? Is this okay? The answer is yes, okay? So if you do not have a significant enough things that you need to handle, it's not a particular, really a use case that is that important to model, it is perfectly fine to bypass the application layer. One good example of it is finders, okay? So find this record, right? Here's an ID, find this record. Okay, this does not require, there's no need for an interface layer in this case. You can directly access a repository and simply access a getter to do that, right? However, you should try to do that sparingly, all right? So don't overuse this because then you're getting back to that Uber component situation, right? So you should try to do that sparingly. However, you are permitted to do so, right? Domain-driven design does say it's fine to do so, and in fact, there are cases where there's a legitimate reason to do that. Yes, sir. Okay, so the question here is, I think what you're trying to ask is, what if you need to talk across aggregates, right? I think that's what you're really asking, right? So the answer is, there's a couple of different answers. So in domain-driven design, there's nothing saying that you cannot have cross-links between aggregates. Okay, you can have that. It's perfectly reasonable to do so. Again, you should do that sparingly, right? You shouldn't have that all over the place. If you're doing that, then you've probably structured your aggregate somewhat incorrectly, right? But the more manageable way, okay, to do so, and it's something that you should strive toward, is when you have these cross-aggregate interactions, to do that at the application layer. Okay. Yes, sir. Pardon? Simple CRUD use case. Yes. Yes, most certainly. Yeah. Okay. We'll talk about that in a second. So the most obvious one is database access code, right? Your JPA code, right? To say entity manager.persist, entity manager.retrieve, and those are bits of infrastructure code, right? So they really belong in part of the below the domain layer, right? So you're going to interpose infrastructure on the domain layer. Some other examples are at the interface layer. You may have artifacts for those if you're using JSF, managed beans, okay, and perhaps accessors and mutators for those managed beans. Your facelet pages. Those are again parts of infrastructure. They're not really true parts of your domain. So you should try to isolate them, and I'll show you how you do that in code if we get to the code. Which if we don't, I'm not going to be heartbroken. Okay, yes, sir. You're having a hard time distinguishing between services and the application layer. Okay, all right. The application layer is a level above your domain model. Okay, services are part of your domain model. That's the biggest distinction, right? Responsibility-wise, again, the responsibility of the service is to model an important action or verb in your domain, right? Sort of a one-off thing, if you will. Application layer is far more pervasive, right? In the sense that it should model every distinct use case that you have in your application, right? Again, I think it'll be more clear when we talk about the example code. Yes, sir. Yes, it's actually very simple. So it's a very, very simple. So everything that we talked about in this diagram, okay, this part of it, right, is all part of your domain, part of your domain, right, the lowest rung on that layer. Everything else is above this. Okay, so that's where you have the layered architecture, right? Okay, any other questions? No, it shouldn't. So what you will do if you have cross connections between aggregates is that you will pass in let's say you're performing an action that requires an aggregate from, rather an entity from another aggregate. What you will do is you'll model the behavior that you're actually modeling. It's typically going to be either part of a service or more typically it's going to be part of the behavior of an entity. And as part of that behavior, you will likely just take the other related entity as a parameter. Or you will, when you do the setup step, when you do the collaboration step, you may invoke a simple setter, okay, to say, please set this related entity because I need it in a subsequent operation. Okay. So your domain logic, your business logic is still not in the application layer. All you're really doing is setting up things. Okay, you're just setting up collaborations. Okay, not necessarily business logic. Yes, sir. In the application part, you have all of the verbs, the important verbs, because think about it in terms of a pardon, coarse grained verbs. Yes, in fact, yes.
And those the application layer then goes ahead and get the whole thing done by communicating with the services or the entities.
Entities and value objects, aggregates and repositories, all of the things in the part of the. Correct. Yeah. So all you're doing there is coordinating. Again, let's take a look at the code example. I think it's much easier to grok there. Okay. All right. Anything else so far? Compositions of services and your domain. Yes. Yep. Okay. All right. Moving on. All right. So this is how you map concepts or design patterns in domain-driven design to technologies in Java EE, in the Java EE platform. And actually it maps quite nicely for 2 reasons. One is that Java EE is relatively modularized. Okay, so each of these technologies actually play a specific role, and for that reason it's easy to map them to a specific bit of responsibility in domain-driven design. Number 2, because it's designed for the enterprise, there's actually some accidental mappings, okay, accidental direct mappings where concepts in domain-driven design map directly to functionality that's available in Java EE. Okay, so let's take a look at this. In the interface layer, you will typically have things like JSF, JAX-RS, WebSocket, Batch, and others. Okay. In the application layer, what are you actually modeling? You're modeling a use case, right? A high-level use case or a unit of work. Okay, so that is a very good place to apply things like declarative transactions, security, monitoring, threat safety controls. Okay, and all of these things, in fact, are modeled by EJB. In fact, EJB, if you create a stateless session bean in particular, it has a very nice mapping with the application layer. The application layer components are usually stateless. They model high-level behaviors, and they are a good place to apply the services that EJB provides largely by default. Okay, so again, a very nice, very nice mapping between EJBs and the application layer components. Yes, sir. So you will essentially create your own. You'll have a POSIO that is an application component Then typically in other systems, you will a la carte add whatever services that you need. You'll add transactions, security. If they have facilities for monitoring, you'll add that. If they have facilities for threat safety, you'll add that. It's just more work. Whereas in EJB, you typically will have those, essentially all those services just baked in, right, by default. Everything, all EJBs are, for example, by default transactional, secured, monitored, threat safe, has threat safety controls and pooled and the like. Somebody else over here had a question. Yes. So the SEAM framework's philosophical thrust actually does not map to domain-driven design that well. Okay. It maps to something called CQRS. Okay. That's called a control command query separation. Sorry. Thank you. Whoever that is. It follows more that pattern, right? And that is part of domain-driven design. But not as I'm speaking about it here. In fact, in my opinion, the CQRS is not that applicable to most systems. So yeah, you can implement domain-driven design in SEAM. There's no problem doing that, right? It's just that you wouldn't make heavy use of things like conversations and lazy loading, right? Those things wouldn't really exist in domain-driven design, at least not the canonical version of domain-driven design. Pardon? Most certainly, yes. So there is another construct that I won't talk about in domain-driven design that is called context maps. Okay, and what that pertains to is when you have a large enough system, it pertains to how you can break down that large enough system into small enough subsystems. Okay, and that is where things like remoting and microservices come into play. Whatever your distributed architecture protocol may be, whether it's REST or WebSocket or EJB remoting, what have you, all of those concepts actually do map to domain-driven design as well. Of course, yeah. With distributed computing comes increased complexity. You shouldn't just do it for the fun of it, right? You should only do it when it actually makes sense. Yeah. Pardon? Okay. Typically. Okay, so in fact, CDI can be part of any of these layers. To be very fair, right? So CDI is going to be glue code for all of these layers, right? So you'll use CDI to glue EJB and the application layer and JSF together. You'll use it to glue together the repository to the domain objects, so on, right? Pardon? You can if it's passivated. Right. You can if it's passivated. But if it has to be a passivatable bean in order to do that. I think let's take that discussion offline because it's not that related to this really. Okay, so where was I? Ugh. I have completely lost my train of thought. No, it's fine. It's fine. What the heck was I talking about? Oh, I was talking about the application layer, sorry. Okay, so that's the mapping between the application layer and the EJB layer. Entities have a very nice mapping with Java EE, okay? So generally, an entity is going to be a JPA entity, okay, with the @entity annotation. It happens to work out very nicely that way. Value objects similarly have a very nice mapping in JPA as well. JPA embeddables are typically going to be value objects, all right? Infrastructure is where most of the Java EE is concerned, right? So there's lots of examples of what you could be doing in terms of infrastructure in Java EE. Okay, so almost every single Java EE API in some shape or way provides some infrastructure services. Repositories will generally be implemented using CDI. The reason for this is it's highly unlikely you'll use repositories without the application layer being involved. Because you have transactions via EJBs at the application layer, you typically will not need you'll not need the repositories to also be EJBs. The repositories will typically just be CDI managed beans, just some plain dependency injection, and not many other services. And most certainly, a big candidate for the repository layer infrastructure code is going to be JPA. Okay, so you're going to write a whole bunch of JPA code in the typical situation. All right, moving on. So I have about 7 minutes left by my watch. Okay, so, yes, sir. Sure. Okay. I think let's do this if we can get to the code real quick, which is going to be highly unlikely. Okay. All right. So I talked about a whole bunch of concepts. Okay. You can see all of these concepts in action, in code. In fact, my plan was to spend a little bit of time, about 10-15 minutes, showing you the code. Obviously, I'm not going to be able to do that. All right. So what I invite you to do is log on onto this website. It's called cargotracker.java.net. All right. That will show you a whole bunch of these concepts in action. Okay. I was going to do a brief walkthrough of it, but I don't think it doesn't look like I'll be able to do it. But the nice thing about it is it's not just a simple website that you just have a download button and that's all. Okay. A lot of what I explained today is going to be explained on that website. The website will have additional resources that I'll also talk through in a moment. And more importantly, there's also a user forum. Okay. So if you have any questions, you can ask the questions in the user forum. All you really need to do is sign up for java.net and you'll be able to use the user forum to ask any questions that you may have. All right. I want to share the resources real quick. All right. And if there's any time left, I'm going to show you a bit of code. All right. So first one is simple, right? Figured that out. Go look at the code. It's all here. You can download it and run it. The second one is a ref card. It's a dzone ref card. It's about 5 pages. Okay. It's very nice. It's written by a gentleman called Asla Khan, whom I know. He's done a very good job of distilling the core parts of domain-driven design in 5 pages. Quite an accomplishment. If you want to read a bit more, there's a thin, about 200-page book available on InfoQ. It's called Domain-Driven Design Quickly. It's free. Okay, you can go and download it. And I actually recommend that's your next step. Okay, after you've whet your appetite with the ref card, you've taken a look at my project. The next step is to read that. What I'll tell you is don't read the big domain-driven design book. Okay, there's a book by Eric Evans. It's about I would say 500 pages. All right. Don't read that because that's what took me 2 years to understand. All right. All right. Other than that, of course, if you want to learn more about Java EE, you're more than welcome to take a look at the official Java EE 7 tutorial. And also, I and a colleague of mine maintain a little blog called The Aquarium. I always like to promote that. If you're interested in the Java EE ecosystem, want to stay up to date, that's a good place to do that. We try to blog every day, okay, on it, and hopefully it's an interesting blog. If you're a Twitter user, you can follow @glassfish instead. Okay, we mirror everything that we say on the Aquarium on Twitter also. All right, so let me show you the code in the remaining 3 minutes that I have. All right, so here's the application. I was going to demo you the application. I'm not going to demo it. It's the name is Cargo Tracker, so it has to do with tracking cargo across the globe. As you can see the layers manifested in the packages that I have, right? So I have an application layer, a domain layer, an infrastructure layer, an interface layer, and so on. Okay. Notice also that my domain is segmented into various parts, right? Cargo, handling, location, voyage. Guess what those are? Those are aggregates. All right. So we can take a look at the cargo aggregate, for example. So that has the cargo object, okay, which is the aggregate root, and a whole bunch of other helper entities and value objects in there. You'll also notice that the repository is in there, but if you look into the repository, it is actually simply the interface. Okay, the actual repository code belongs in the infrastructure layer, and as you'll see, I'm using quite a bit of infrastructure here. I'm using CDI events, I'm using JMS, I'm using JPA. I'm using another bit of infrastructure that I'm calling routing. So the repository is actually in the JPA part of the JPA infrastructure. Okay, there you see a JPA cargo repository. It's one repository per the entire aggregate. All right, now let's dive into this cargo thing. Okay, so here's the cargo root entity. All right, it is a JPA entity, as you can see. Okay, it's mapped by @JPA. It's simply a POJO. It has a relatively complex entity, so it has an ID, but it has other embeddable objects in it. So tracking ID in this case is a value object. Okay, there's also a relationship between location and route specification. Okay, route specification is actually a value object in this aggregate route. Itinerary is a value object in this aggregate route, as is delivery. Okay. Interestingly enough, if you look at location, it's actually a cross-aggregate relationship. Okay, so you can do that. There's an example of that there. Looking farther down, you will see getters and setters, right? We Java developers are famous for writing those, but there's also business logic. Okay, specify new route, assign to route, derive delivery progress. This is all business object. Okay, yeah, if you dig into this code, you'll see that's where the business object really resides. Now, let's take a look at the role of the application layer. Okay, I won't show you the interface layer because there's not going to be time to do that. In fact, I'm out of time. So we will take a look at the default booking service. All right, and jumping down here, you will see the role of the application layer. Okay, so for example, if you look at assign route to a cargo, it takes an itinerary and a tracking ID as a parameter. Then what it does is that it does coordination. Okay, so it's getting the cargo back, and then there's no business logic here. The business logic actually resides in assign route to cargo. Okay, same thing for the other application layer objects that you'll see. It's the same pattern over and over again. It's just coordinating parts of the domain, and of course you'll see other things in here as well. So that is all the time I have. I do have some other talks. Feel free to come to those. I don't think I have so many talks. I don't think I have a lot of time to chat with you, but I will try. Okay, so stop me if you have any questions. I'll be around. Thank you very much. I appreciate you coming.